Everybody can see my screen and और मेरी आवाज सबको आ रही है?
Yes, sir.
जी, sorry.
Yes, sir.
Okay, thank you very much. Okay. Okay, ji. Bismillahirrahmanirrahim, ji. Welcome to week 6 in steel structures. Okay. First, we will discuss the leftover part, which was about tension member. So we discussed tension member, okay, and we didn't discuss the design of tension member, okay. So in the first half of the lecture, we are going to discuss the design of tension member, okay. And in this slide, you can see that there are two approaches. As you know that there are two approaches we are following for the design and analysis of our members or steel structures, which we call LRFD and ASD. If you look at the LRFD, so under the LRFD, there are certain steps that are given, and these steps represent the design steps of tension member, okay. The first step is whenever you are going for the design of any tension member, you have to calculate the demand, okay. And the demand means is represented by the ultimate load, or it will be, because we are sure that we know that the load, axial load, is acting on the tensile members, okay. We do not have any bending moment, okay. The first thing is that you have to calculate the load which is acting on the tension member. The second step is that you have to check for the two limit state, as we have discussed in our last lecture, that we check for excessive deformation, okay. This is excessive deformation. And for excessive deformation, we know that we use phi value, strength reduction factor of 0.9, okay. And the third step in design of tension member is to calculate the net area, okay. And this, we know that the second limit state we are going to check for tension member is the fracture, okay. Fracture limit state. And in this case, the strength reduction factor we use is, it has a value of 0.75, okay. So the first step is that you calculate the axial load or the demand which is present on the member, and the second step is determine the gross area, cross-sectional area. In the second step and in the third step of tension member, according to LRFD, is that you calculate the cross-sectional area. And the third step, the fourth step in tension member, we check the slenderness ratio, okay. So this is slenderness ratio, okay. Slenderness ratio, okay. Oh, in other words, you can also say that we check for the stability of the tension member, okay. So like there are 4 steps that you have to carry out for follow based on the LRFD approach. First, you have to calculate the axial load. Second, you have to calculate the second and third step, you have to calculate the cross-sectional area. And in case of excessive deformation limit state, the cross-sectional area is represented by the gross area of the member. And in the fracture limit state, the cross-sectional area is represented by either the net area or the effective area, okay. So we know that we are familiar with, because we went through some of the analysis of tension member, and we discussed in our class that why we calculate the cross-sectional area. We calculate the cross-sectional area because the area, cross-sectional area, is the sole, you can say the sole determinant of the tensile member, So that's why we calculate the cross-sectional area, okay? So please remember that there are two limit states we have to check for tension member. The one is the excessive deformation, which is represented by the FY value for yield stresses in your member. And the second is again the yield stresses, okay? Let me check that, is it yield stress or is it ultimate stress? We have to check that, okay? We have to check that this value is FY or FU, okay? It will get clear when we will go to the example. So basically based on LRFD, you have to follow these steps in order to design any member, okay? And the additional step that we didn't discuss in the analysis of tension member is the slenderness ratio, okay? Or the stability check. And this stability check is represented by length of the member by the ratio of least radius of gyration, and this value should be less than 300, okay? So this is the stability check, okay? Basically there are 4 steps you have to follow in LRFD approach. Similar to LRFD approach, in the AST approach, you have to calculate the demand, you have to calculate the cross-sectional area based on excessive deformation, you have to calculate the net area based on the fracture limit state, and finally you will check for the stability of that member. And this, in this case, the stability is checked by the same formula, okay? What is L in this equation? L is the length of the member, okay? And what is R? R is the radius of gyration, okay? When you look at the manual, so you can find this value, okay? Where there are R should be R minimum, so it will be between this value and this value. Whichever value is less, so you are going to use in this check, okay? आप लोगों को समझ आ रही है? Is it clear to you that how we can carry out the design of tension member?
Yes, sir.
Yes, sir.
Okay, thank you very much. The additional check is that stability check. Remember from the first class that I told you that in steel structure we also check for the stability, okay? So we will quickly go through an example to demonstrate this design procedure, okay? Now the design procedures we want to demonstrate, okay? Design procedures, or what are the design procedures? Like the LRFD and the AST approaches we have discussed in our last slide. So this is an example. This example you can also find in the Segway book, okay? So the statements, it is stated that there is a tension member with a length of 5 feet and 9 inches. So immediately when you look at this statements, you should recognize that the length of the member is 5 feet 9 inches, okay? Or another word, you can say that this is 5.75 feet, okay? So, and it must, okay? Now this tension member must resist a service dead load, which you can see is about, has a value of 18 kPa, and it should also resist a live load, service live load of 52 kPa, okay? So the first step, as you remember, like in from the previous slide, okay, now is to determine the demand. And how we can determine the demand, okay? We know that when we have these, oh sorry, this is live load, okay? We have 2 type of load, so we can check the demand, or we can calculate the demand using the load combination based on the nature or the types of load which are present on the member, okay? First you can do it with this load combination, and the second load combination, which is controlling in the most of the cases, is about this 1.2 times the dead load plus 1.6 times the live load, okay? So when you do that, you will get this PU, or the demand on your member, okay? So this step has been, this check has been performed, or demand has been calculated, and this demand comes out to be 10.48, okay? So this is your PU value. Now the second step, as you remember, that we have to check, or we have to calculate the cross-sectional areas based on 2 limit state, okay? So the first limit state is the excessive deformation, which is represented by the yield stress, okay? Now, if you go there, if you go to this step number 2, so the demand, we already know this is 104.8. Sorry, this is 104.8 kips. So now the phi value, as I told you, that in excessive deformation the phi value is 0.9 and Fy value. So where we will get this Fy value? So we will come to the statement, and in the statement of the problem you will see that it is asking you to use the A36 steel. Okay, and for A36 steel, the Fy value are 36 ksi, and ultimate stress is 58 ksi. Okay, so these value you should, when you look at the type of material, you should immediately recognize that what would be the yield and what will be the ultimate stresses that will be developed in this member. So when you first calculate the gross area, okay, now the gross area comes out to be 3.235 inch square. On the second check is about the fracture limit state. In the fracture limit state, you can see that in the last slide I told you that whether this value will be AN or it will be AE. Okay, why we are using AE? Anybody from the class, that why not we are using this value? Why not this value? Any comment
सर
from the
shear
class?
lag नहीं होगा सर.
G?
There will be no shear lag.
There will be a shear lag because you look at the statement. So it is asking you that this is a bolted connection. Okay, we will see that AN is equal to AE, and you are probably right that about this problem that there will be no shear lag. Okay, if there is a shear lag in your member, then A net is not equal to A effective, and then in this case you have to use this relationship. Okay, sorry, this is N and this is effective. Okay, so there is no shear lag, and we will see that why there is no shear lag in this problem. Okay, now when you look at this problem, so you have this gross area, you have this effective or net area. So now you need to select a cross section. Okay, you can go to the manual, you can select an angle, okay, which has a gross area of about 3.235 or the greater than this value. Okay, any angle having a gross area greater than 3.235 inch square will work. Okay, once you have the gross area, you have the bolts that are installed in this member, so you need to calculate the net area. Okay, if you are using the net area, and eventually you have to calculate the effective area. So if you are using this member as your member that as a that you want to select as a tension member, then in this type of member you will have this shear lag. Okay, why we will have shear lag in this type of member? Any
क्योंकि sir
question?
only one part will be connected.
Yes. Okay, if you are using this member, one plate like this, so do you think that there will be shear lag in this member?
No sir.
Yes, there will be no shear lag. Okay, no shear lag, no shear lag. You can do, you can assume any thickness, then you can calculate the width of this member, because the gross area we already know. Okay, once you divide this width by gross area by the thickness, so you will get the width. Okay, so you will say that let's assume a cross section having these rectangular dimensions. Okay, 1 into, now this is the thickness and this is the width. Okay, so you can try this member. Okay, now what we are going to do, we are going to check that the gross area of this member is greater than this or is it less than this value. So the gross area, we know that for this member the gross area is equal to 3.23 inch square. Okay, Now we will calculate the net area. Okay, how we can calculate the net area? So we will subtract the area from the grass area. So the grass area, we know this is the grass area. No, this is not the grass area, I'm sorry. This is this one, but this is for this the grass area is 3.5 inch square. I'm sorry. So the grass area you can calculate. The bolt diameter is 1 by 7 by 8 inches, and if you add 1 by 8 inch clearance, so you will get the diameter of the hole. Okay, so then you have to multiply it with the thickness. So in this way you will get the net area. Okay, this is the net area, and the net area is 2.5 inch square, and the required effective or net area is 2.409 inch square. So this area is greater than this value, so the selected member is fine. Okay, we can use this member
सर
because
ये 7/8 + 1/8 किस तरह है सर?
हाँ, ये इस तरह है ना कि जब आपके पास ये जो 7/8 है ना, दिस इज द डायामीटर ऑफ बोल्ट. ठीक है, वी आर इंटरेस्टेड इन डायामीटर ऑफ होल. और होल का डायमीटर क्या होता है कि डायमीटर ऑफ बोल्ट प्लस अ क्लियरेंस ऑफ 1/8 inches. The hole is always, it has a higher or it has a larger dimension than the bolt, and this is about 1/8 inches, एक सूत्र. So in this way you can calculate the diameter of the hole if you know the diameter of the bolt. ठीक है?
Okay sir.
Okay. Now the important thing is that, as we have seen, or somebody have from the class has pointed out, that in this case net area will be equal to the effective area, because there will be no shear lag in this case. Okay, अगर किसी को समझ नहीं आई तो पूछ सकते हैं. ठीक है, कि why if अगर किसी को ये समझ नहीं आई कि why AN is equal to AE in this case. ठीक है, तो वो पूछ सकते हैं. अगर आ गई है तो ठीक है, अच्छी बात है. सबको समझ आएगी है कि why this area. अच्छा, इसका मतलब ये है कि when you have, there is no shear lag, there is no shear lag. ठीक है, तो in this case net area is equal to effective area. Otherwise, if you have a shear lag, then effective area is not area. Effective area is equal to net area by this relationship. Okay, this means that you have to calculate the U value, and the U value you can calculate like by this relationship. Okay, angle, और आपके पास डबल एंगल, a built up section, you want to use a built up section, और ये दोनों जो हैं they are connected with the help of a plate, a gusset plate. ठीक है, or only this part is connected. Okay, this part is connected, this part is not connected. When one part is connected and the other part is not connected, so the stresses will be not uniformly distributed. Okay, this will be in the fully stressed condition. This part of the angle will be in fully stressed condition, and this part of the angle will be not in the fully stressed condition. There will be a lag. Okay, in the stresses that are developed in this member. So this, when you have this type of scenario, we call that there is shear lag. Okay, and in this case effective area is equal to net area by this relationship. Okay, and this is valid for the bolted connection. bolted connection. Okay, if you have a welded connection, in that case the effective area is equal to, you will use this relationship in case of welded connection. Okay, okay, is that clear to all of you?
सर इट्स क्लियर, लेकिन सर डेली लाइफ में हम जो देखते हैं ट्रस ब्रिजेस या सर, उसमें तो एल सेक्शन यूज होते हैं।
नहीं, वो एल सेक्शन को हम एंगल सेक्शन कहते हैं ना, इसको एंगल कहते हैं। ठीक है, ठीक है, एल जो होता है ना, ये इसको हम आप कहेंगे एंगल सेक्शन यूज होता है। ठीक है, अगर उसका ये पार्ट भी, ये साइड भी वेल्डेड है और ये साइड भी वेल्डेड है, ठीक है, सो नो शेयर लैग, यू विल नॉट कंसिडर शेयर लैग फिनोमेना। ठीक है, अगर आपका सिर्फ ये वाला पार्ट वेल्डेड है या बोल्टेड है और ये वाला नहीं है, तो देयर विल बी अ शेयर लैग, यू हैव टू कंसिडर द शेयर लैग। ठीक है,
ओके सर।
अच्छा, now as I told you, in the design of tension member we have to check the stability or slenderness. ठीक है, stability check, why we want to perform the stability check? देखें, बात तो ये है, अभी डिस्कस करते हैं कि टेंशन मेंबर में why we want to check the stability, क्योंकि इसमें तो एक्सियल लोड इस तरह एक्ट कर रहा होता है, तो जरूरी नहीं है कि ये बकल करे, लेकिन हो सकता है कि देर इज स्मॉल एसेंट्रिसिटी इन दिस लोड। ओके, एसेंट्रिसिटी हो सकती है, या जब ये लोड हट जाए तो इसके ऊपर कोई लेटरल लोड यहां से आ जाए। ठीक है, सो दिस मेंबर कैन बिकम अनस्टेबल। Okay, that's why we want to we check we apply the stability check, also apply the stability check in design of tension member. And as I told you that how we can check the stability, we can check by this simple formulation, L by R. Okay, now R is equal to radius of gyration is equal to I by A. Okay, now as I told you that you have to use the minimum radius of gyration. Okay, so you can check for this simple plate, you can calculate the moment of inertia at its centroid. This comes out to be this one. Okay, मतलब आपका मेंबर इस तरह है, 3 by this is 3 by 5, 3.5, 3.5, तो आप ऐसे अप्लाई कर सकते हैं। इस एक्सिस के अलावा यू कैन डिटरमिन द बेंडिंग मोमेंट ऑफ इनर्शिया। आप ऐसे भी कर सकते हैं, यू कैन कैलकुलेट द मोमेंट ऑफ इनर्शिया ऑन अलोंग द वाई एक्सिस, देयर आर 2 एक्सिस। ओके, सो जिस एक्सिस पे आपको मिनिमम वैल्यू मिलेगी, यू विल यूज दैट, यू विल टेक दैट वैल्यू। ओके, इन दिस केस the minimum value is about along this x-axis. Okay, so if you calculate along y-axis, so it will be about 1 into 3.5 cubic by 12. So this will be maximum I value. So if you calculate the moment of inertia, or you calculate, you have moment of inertia, you have the area of the member. So using this relation, you can calculate the minimum radius of gyration. This minimum radius of gyration comes out to be 0.2887. I'm not sure it is square. You have to check. So once you have the least radius of gyration, you also have the length of the member. So what you can do, that you can put this value in this equation, and you can check that whether or not you are getting a number less than 300. Okay, if you are not getting the a number that is less greater, if you are getting a number L by R or slenderness ratio number that is greater than 300, what you have to do, you have to increase this radius of gyration, or then you have to change your design, you have to revise your design. Okay, so this is okay, the grass area is okay, we have checked in LRFT that our grass area is okay, our net area is okay, our L by R ratio is okay. So this member we can use as a tension member. Which member? This member, sorry, this plate member we can use as a tension member. Okay, this is fine. Okay, Now the next approach is AST approach. In AST, what you do, you do not use any load factors. You calculate the PU value. Based on this PU value, you can calculate the gross required area. So you can calculate this area using this formulation. Okay, the yield excessive deformation case, the allowable stresses in the member are 60 times the yield stresses. And then you using these stresses, you can calculate the gross area. Okay. Similarly, you can calculate based on the fracture. The allowable stresses based on ASD will be 29 KSI. So based on these values, you can calculate the effective area. Now you have calculated the effective area. You have calculated the gross area. Now you will check that. Now, okay. Now we will check that this member having this dimension, what is the gross area and what is the net area. The net area is 2.5 inch square, which is greater than this one. And the gross area is about 3.5 inch square, which is greater than this value. Okay. Now we will apply the stability check. Okay. The stability check you can apply. We have already applied that L by R. L by R was about 239. And this was less than 300. So the stability check is also fine. The areas are also fine. So it means that based on LRFT, and then based on AST, so you can use this member as a tension member. Okay.
Sir, what is this FT, sir?
Sorry?
FT, sir. ये FT क्या है?
MT किधर है बेटा?
Sir, FT is equal to 0.5 FU.
हाँ, FT are the allowable stresses. Okay. Allowable stresses. ठीक है. मैं एक सेकेंड आप रुक जाएं, सब्र करें. अच्छा, this is FT. Okay. ये वैल्यूज है, ये वैल्यू. ठीक है. अगर आप पीछे चले जाएं, अपने आप मेमोरी को रिकॉल करें, तो मैंने आपको बताया भी होगा यहाँ पे कहीं पे कि ASD में हम क्या करते हैं. यस, ASD में हम क्या करते हैं, either you can use this approach for fracture or for the yielding or excessive deformation. Either you can use this formulation or you can use this value of allowable stresses. And for fracture limit state, either you can use this value, this formulation or this formulation. So basically उसमें आप जो देख रहे हैं 0.6 FY into AG and 0.5 FU into AE, ये फॉर्मुलेशन वहां पे यूज हुई है. ये ठीक है. प्लीज गो थ्रू दिस प्रॉब्लम. ठीक है. अपने उसके लिए कौन सा 3.2, ठीक है, उससे पहले भी इसमें दिया होगा कहीं पे. यस, आप इस प्रॉब्लम यू शुड गो थ्रू इट. आपको क्लियर हो जाएगा कि आप ये यूज कर सकते हैं और ये भी यूज कर सकते हैं. तो उस एग्जांपल में ये यूज होगा 0.6 FY and 0.5 FU. क्लियर हुआ आपको?
सर इट्स क्लियर, बट द क्रॉस सेक्शन वी हैव सिलेक्टेड सर, ये बहुत इम्प्रैक्टिकल नहीं है.
हाँ, this is for the demonstration purposes. Okay, so if I want, you can repeat this problem. Okay, you can repeat this problem. Repeat this problem. If I ask you to use an angle, any angle, or I can say equal leg angle, तो आपके पास तो AG भी नहीं है, आप क्या करेंगे? Then you will have to go to the manual. ठीक है. मैनुअल में कैसे जाएंगे जी? अगर if I ask you to use a wide plane section, any wide plane section पे भी आप कर सकते हैं इसको. आप एंगल पे भी कर सकते हैं, ठीक है, ये है। लेकिन मसला ये है कि आप इसका एजी कैसे मालूम करेंगे। आप रिक्वायर्ड ग्रॉस एरिया भी मालूम कर सकते हैं, आपके पास इक्वेशन है। आप रिक्वायर्ड नेट एरिया या इफेक्टिव एरिया भी मालूम कर सकते हैं। लेकिन देन यू हैव टू सेलेक्ट अ मेंबर, सेलेक्ट मेंबर, क्रॉस सेक्शनल शेप, क्रॉस सेक्शनल शेप। वो शेप प्लेट भी हो सकती है, वो शेप एंगल भी हो सकता है, वो शेप वाइड फ्रेंच सेक्शन भी हो सकता है, वो एक चैनल भी हो सकता है। इसके लिए यू हैव टू कंसल्ट मैनुअल, ठीक है, उसके लिए यू हैव टू यूज दिस मैनुअल। In the manual you have these cross sectional properties like R minimum, you can find gross area, you can find R, like there will be two moment of inertias, there will be two radius of gyrations, okay, this is Z, sorry, this is Z, और आपके पास ये सारी चीजें उसमें से मिल जाएंगी। आपने क्या करना है, यू हैव टू जस्ट पिक द सेक्शन, ठीक है, एंड यू विल पिक द लाइटेस्ट सेक्शन आउट ऑफ मेंबर्स, आउट ऑफ अवेलेबिलिटी, जो आपके पास अवेलेबल हो। या आपके पास एंगल अवेलेबल नहीं है तो आप क्या करेंगे, आपके पास प्लेट्स अवेलेबल हैं, देन यू हैव टू सेलेक्ट अ प्लेट मेंबर, ठीक है। अगर आपने ये रिक्वायर्ड कैलकुलेट कर लिया तो देन यू हैव टू सेलेक्ट अ मेंबर। तो मेंबर के लिए क्या करेंगे, यू नीड दिस एजी वैल्यू, ग्रास एरिया आपको चाहिए। जब आपको ग्रास एरिया चाहिए तो देन यू कैन कैलकुलेट द नेट एरिया, एंड सिमिलरली यू कैन कैलकुलेट द इफेक्टिव एरिया, ठीक है। तो प्रोसीजर वही है। अगर आपने स्टेबिलिटी चेक अप्लाई करना है तो स्टेबिलिटी चेक के लिए आपको ये परफॉर्म करने हैं। आपने लेंथ गिवन है, ये आपको चाहिए, तो ये आपको कहां से मिलेगा, ये कहां से मिलेगा, ये कहां से मिलेगा, मैनुअल से मिलेगा, ठीक है जी। अभी आपको समझ आई थोड़ी सी?
यस सर।
बोर तो नहीं हो रहे आप लोग? आर यू गेटिंग बोर?
नो सर।
Okay, let me summarize that we have to for design of tension member, first step is, step 1 is to determine the ultimate load या demand, and that is represented by this PU value. The second step and the third step is to determine the required gross and net area or effective area. The third step is, fourth step, select a cross section, okay, and check. Step 5 will be check the gross and effective area of the cross section, whether it is greater than the required gross and required effective area, okay. The last step is stability check or slenderness ratio. This slenderness ratio is performed by this formulation. ठीक है जी, क्लियर हो गया आपको ये टेंशन मेंबर?
Yes, sir.
Yes, sir.
Acha. Okay, now we will go through another tension member, design of tension member example. And in this, if you look at the statement, you have to use an unequal leg angle. Unequal का क्या मतलब है कि you have to select an angle जिसकी legs आपस में they are different, lengths are different. Okay, and the length of the member is given. The length of the member is 15 feet. So immediately L is 15, and it has to resist a service dead load of 35 kPa and service live load of 70 kPa, and the Fy value, and you have to use A36 steel. The Fy values are 36 ksi, and the Fu value is 58 ksi. Okay, now the first step is you determine the demand. Okay, you have to select the diameter of the bolt is 3 by 4 inches, and the whole diameter will be 3 by 4 plus 1 by 8. Okay, so first you have to calculate the demand. So the demand is 154 kips axial load. Then you have to calculate the required gross area, required effective area. Okay, gross area, you know that this value is here. Okay, now you can calculate the required. This comes out to be 4.75 inch square, and the effective area comes out to be 3.54 inch square. So now you have to you need to have this value. Okay, you need this value, R minimum. Okay, you need this value, but we know that R is equal to, or it should be L by R, sorry, should be less than 300. Okay, if you do the cross multiplication, so L divided by 300 should be this much. Okay, so you have to select a member which has a radius of gyration about this. Okay, like the length is 50, and if you do the calculation, this comes out to be 0.6 inches. So you will select an angle which has a radius of gyration equal to or greater than 0.6 inches. Okay, so if you go to the manual, okay, now you have this guideline that the R minimum should be greater or equal to 0.6 inches, and the gross area should be this much. The gross area is 4.7 inch square. Okay, and the net area, you can calculate the net effective area. Okay, the net effective area should be greater than or equal to this value. So it is stating that you should go to the manual and you should try out this section. Okay, L6 4 into half. Okay, this is the first leg, this is the second leg, this is the thickness. Okay, and for this angle, the gross area is given. The gross area is 4.75 inch square. Now you will calculate the net area. Okay, if you want to calculate the net area, so you have to subtract the number of holes from the gross area. And if you look at this problem, there are 2 rows of bolts. Okay, the net area in it, you have to select or you have to subtract 2 holes out of the gross area in order to get the net area. Okay, in the last example we had, let me check, where is that problem? It says there is a line of bolts. Okay, so that's why we subtracted just 1 whole area. Okay, now in this example we are going to reduce, or we are going to subtract the 2 holes area from the grass area. Okay, so if you look at, if you we come to this slide, so you will see that there are two holes. Okay, this is the diameter and this is the thickness. And why we are, where we are getting this thickness? Because we are using 6 by 4 by 1 by 2. This is the thickness. Okay, this represents the thickness. Okay, so the net area is 3.875 inch square. Sorry, 3.875 inch square. Okay, but since we are using this type of angle member now, angle. Okay, now the net area is not equal to effective area. The net area is related to effective area using this relationship. Okay, so now you can use simple guidelines. So this is saying that U value is 0.8. It is given. Okay, or you can calculate the U value using 1 minus X bar by L. X bar, you will get it from the manual. Okay, and what is X bar? Let me repeat it here. If this is an angle and this is the centroid of this angle, now this has to be connected at this very last end. So this is that X bar, and you can find that in the manual. Okay, if you go to this manual, so you will get the centroid. Okay, so you can use this formula. What is L? L you can calculate using this length. This is L. Okay, we have discussed about this U computation, factor computation in the last class. Okay, so you can calculate the effective area. Effective area is 3.1 in 3.1 inch square, which is less than 3.54 inch square. So excuse me, the net area or the effective area is less than, so we are, this member is not satisfactory. We will try out another member. So and that member happens to be this one. It has a thickness of 5 by 8 inches. Now from the manual you can find the gross area of this member, which is this much. Minimum radius of gyration is 0.76, which is greater than 0.6 inches. So this is fine. Now calculate the net area. Okay, now you will see that this is replaced 1 by 2, this is 5 by 8. So this comes out to be 3.836 inches. Okay, this area, net area. Oh no, then you have to calculate the effective area. The effective area is 3.70 inch square. Okay, this is less than 3.5, and this, what is this is the required net area. Required. Okay, now this is also not satisfactory. You will try another member. Okay, let's try this member. Now you calculate the net area, you calculate the effective area. If the effective area is greater than this required effective area, so this is fine. We know that the grass area is already greater than the required grass area, so this is fine. The area requirements are satisfied. Okay, and similarly we do not have to perform the stability check, or you can perform the stability check using this formulation. Okay, slenderness check, just this one, because we concluded that we will select a member which has a radius of gyration greater than 0.6. So the minimum radius of gyration for this member is greater than 0.6. Okay, so this shape works for LRFD approach. Okay, now we have to use the same approach, the same member we can check with the ASD approach. Okay, so ASD approach, you calculate the required net, gross, minimum. So you calculate the net area, you calculate the effective area. Effective area is greater than the required area. Okay, so this member will work for ASD as well. Okay, now this L8 F4 is satisfactory based on LRFD and AST. Okay, now what I would like you to do is that you should go to this manual. Okay, now what is that? Yes, you should find this shape, and you should find this value. I think, what is the value? 5.8. And R minimum is about 0.863 inches. So please download the manual, or if you have already downloaded the manual, go to the manual and find this section and see that what are the gross area and what are the minimum radius of gyration for this section. You have 5 minutes. Okay, this is a class activity. ठीक है? ठीक है जी, आप ये करें जरा, क्योंकि मिड टर्म नेक्स्ट वीक में है, तो मिड टर्म में आपको ये मैनुअल यूज करना पड़ेगा. Right now it is about 1:09, so I will ask you at 9:06. Okay, आप लोग कर रहे हैं ना ये?
सर डाउनलोड करना स्टार्ट किया.
करें जी, अभी अच्छा है कि अभी कर लें, बेहतर है.
Sorry, sir, I got disconnected and now I'm connected again. So, what's the class activity?
Class activity is that you have to download the manual and you have to find this section. And for this section, find this that is it correct that the gross cross-sectional area for this member in the manual is 5.8? The minimum radius of gyration is 0.863 for this member. This is the class activity. ये चीज आपको मिड टर्म में करनी पड़ेगी, अभी कर लें, एटलीस्ट डाउनलोड तो कर लें आप मैनुअल।
सर ये तो $200 का है।
भाई मैंने मैनुअल क्लासरूम में अपलोड किया है, उसको डाउनलोड करें।
अच्छा सर।
हाँ नहीं यार, आप लोगों को ये भी नहीं पता कि मैनुअल भी है कोई। जब कोई कर ले तो मुझे बता दें।
सर 5.75 है मैनुअल में।
अच्छा, कौन से चैप्टर में है?
140 में, पता नहीं है, पेज नंबर 140 पे ये लिखा हुआ है।
अच्छा, चैप्टर नंबर 1, ठीक है, 140। अच्छा, और मिनिमम ये कितने?
क्या सर?
ये रेडियस ऑफ गायरेशन, आपके पास दो रेडियस ऑफ गायरेशन होंगे।
यस।
एक ये होगा, एक ये होगा। है ये?
एक सर 2.55 है रेडियस ऑफ गायरेशन।
और दूसरा?
और दूसरा सर, दूसरा नहीं गिवन इस टेबल में।
सर सही है, ये 0.863 ही है।
ये कौन से पेज पे, जरा अपने कोलीग्स को भी पता चले ना, कौन से पेज पे आपने देखा? ये अभी कौन थी ये, आप जरा बता सकती हैं कौन सा पेज और कौन से चैप्टर में देखा आपने ये?
सर टेबल 17 पेज नंबर 47।
अच्छा चलें जी, अब मुझे ये बताएं कि अगर मैं आपको एक प्रॉब्लम दे दूं और उसमें आपको मैं कहूं कि एंगल की बजाय आप ये सेक्शन यूज करें, तो आप लोग कर सकते हैं?
यस सर।
फिर आपको इसकी क्रॉस सेक्शनल प्रॉपर्टीज देखनी पड़ेंगी। अगर आपको कोई कहे कि चैनल यूज करो, तो आप लोग उस मैनुअल को यूज करते हुए, अच्छा टेबल सबर करें लिख दूं यार, ये मेरी तरह के स्टूडेंट होंगे तो उनको नहीं पता चले। टेबल 17, ठीक है, अगर आप मैनुअल में जाएं तो टेबल 17 में यू विल फाइंड एंगल्स, और बहुत से एंगल्स होंगे उसमें, तो देन यू कैन फाइंड दीज वैल्यूज, ठीक है। इसी तरह इन्हीं टेबल्स में चैनल्स के लिए भी होंगे, वाइड फ्लेंज सेक्शंस के लिए भी होंगे, ठीक है। तो अगर टेंशन मेंबर, अगर मैं आपके मिड टर्म एग्जामिनेशन में पास करें, मिड टर्म में अगर कोई डिजाइन आ जाए और मैं आपको कहूं एंगल की बजाय चैनल करें, या मैं ये चीज चेंज कर दूं, ये 36 की बजाय मैं दूसरा कुछ कर दूं, तो आप लोग इसको कर सकेंगे, ठीक है, सही है। अगर इसको चेंज कर दूं या शेप को चेंज करूं, कोई मसला तो नहीं होगा ना, सिर्फ FY वैल्यू चेंज होगी ना, ये वैल्यू चेंज होगी,
सर कोई
बस ठीक हो गया। इसी तरह आपको ट्रेन करना है हमें, सही हो गया। अच्छा जी, Next is that as we went through the calculations, how we can do, where we can carry out the design of tension member. Next, there are some tables which are given in the manual, or these tables are the design aids which you can use to facilitate the design procedure. Okay. Now the example 3.12, which we did it with the manual approach. So if you what is that example? Let me go through that example. Yes, the same example we will do it with the help of design tables, or design aids in the manual. Okay. So in the if you go to chapter number 5, if you go to this page, so you will find in the column 1 you will find the shapes for angles. Okay, you will find its gross area, you will find its effective area, and you will also find the design strength based on LRFT approach for the excessive deformation. You will find the design strength for the rupture limit state, you will based on LRFT, and similarly you will find the design values are based on ASD as well. Okay, so for this you have to go to the manual. Okay, in your manual you go to chapter number 5. Okay, this represents chapter number 5. You can go to table 5. Okay, table 5.2. Okay, so in you will, these are the design aids. Okay, they represent the design aids. Okay, so in this table, as I told you, that there is an effective area. Okay, the effective area is these tables have been developed for different materials. Like this table 5.2 is developed for A36 steel. Okay, so you can directly come to the shape and you can directly see the design strength. Okay, like for example, the demand, we know that this is 154 kips. So you can come here and you can select a shape based on these strengths. Okay, for example, you can, if there is this angle 6 angle 8 6 into 1, it has a capacity excessive deformation of 421 kips, and in the rupture it is 424, and this is greater than this PU value. You can select this shape, but this will be not economical. So you have to find a section which is giving which is giving capacity more than this value, which is higher than this value. Okay, simply you have to select the shape and you will see that what is the values you are getting based on the yielding and the rupture. The problem with this table is that in this table we have effective area is equal to 0.75 gross area. The U value is fixed, but we know that U value cannot be fixed. VU value is variable. U value you can calculate using this equation. Okay, so this is the drawback. If you have this scenario that effective area is equal to 0.75 gross area, okay, otherwise you have to do some iteration in your calculation. So let's do that. We are doing the same example. That example is 3.12, and the demand based on LRFD approach is 154 kips. Okay, now if you go to that table, so we will find that the shape unequal leg angle, this angle is giving me yielding, it is giving me a capacity of 154, and in the rupture it is giving me 155. These two values are at least equal or greater than this value, so you will say, okay, this is the right, or this is the section, this is the design section. But wait, you have to check that. Is your effective area equal to U times 0.75 gross area? If this relation holds, so you can directly select or you can use this table. Otherwise, you have to do iteration. And what are those iteration? Okay. Now, if you remember that this is from the same example. Okay, the minimum radius of gyration should be greater than 0.6, this much. Okay, so okay, now if you remember in the example 3.14, the u value was 0.8 and we were using a bolted connection. The effective area was related to the net area. Okay, so the effective area in example 3.12 is this much, which is different than what is the assumption in the table, that effective area is equal to 0.75 this. So this is not right. So we have to check this one. Okay, this all the what I have said or I have explained, so this is all mentioned or scripted in this description, you can see it. Okay, so now we have to check our effective area. Okay, now we have selected a member. Which is that member? This member. Okay, now we will check that the grass area is 4.75 inch square. Okay, so we will see, come here, we will see that we will calculate the net area. Okay, there were two rows of boards. You calculate the net area, you calculate the effective area. The effective area is 3.1 inch square. Okay, and if you go back to that area, the effective area in this case is 3.56, and what we are getting here is 3.1 inch, 3.1 inch square. So this is less. Okay, now if you calculate the capacity in the fracture, so this capacity comes out to be 135 kips. And if you come back to this table, the capacity in the rupture is 155, but actually with this u value and this effective area, you are getting this value. So what you are going to do, that this is the net area and this is the grass area. So the ratio is 0.65, and this is the ratio between the net and grass area. And in the table, this ratio is, in the table, this ratio is 0.75. Table 5.2. So you are going to do a modification, and what is that modification? That the demand should be multiplied by these ratios. Okay, 0.775 by 0.65. Okay, so you will get a new demand. Okay, now you have to select a shape for this demand. Okay, now you enter the table and you will see that a member has this member. Let's see, is it there? No, it is not there. You have to see in the manual. So if you go there and you select that for yielding, the capacity is 188, and for rupture it is 189. Okay, so now the minimum is 0.863. Okay, now you can go to the manual again and you can select the member. So this is the selected member. Okay, and it has a capacity greater than 177, and 177 is the modified demand. Okay, the new demand. Okay, so you will again come and you will again see that you will calculate the net area, effective area, and you will check that whether your capacity is greater or is it less. Okay, so if all the things are fine, if the areas are equal or greater than the required areas, and so and your capacity is greater than 154, so this is fine. Okay, now you will do that for the same thing for the ASD approach. Okay, and you will go through all these things. Okay, so if you go to the table, and in the table the capacities are mentioned like this. Okay, and this factor of safety is 1.67, and this factor of safety is 2.0. Okay, so you have to go through the same procedure and you have to select a member. Okay, so once you select that member, so the LRFD and AST, okay, let me see, LRFD is recommending angle which has these dimensions. Okay, and ASD is recommending this angle. Okay, so there is a difference. So both LRFD and ASD are not recommending the same section. Okay, sections are different. Okay, this is L8, this is L6, 4, 5 by 8, and this is L, what is that, L4, yes. G, now you can ask any questions if you have, you may have. Okay, G.
सर एक्चुअली ये 1/2 इंच और 1 इंच का जो आपने सर ये थिकनेस ऑफ मेंबर्स बताएं सर, ये कहाँ पे यूज होते हैं? हमने जो रियलिटी में देखे हो तो सर ज्यादातर 1/4 इंच थिकनेस और या मैक्सिमम 3/8 इंचेस थिकनेस इस तरह के होते हैं।
देखें, अगर आपकी डिमांड ज्यादा है ना, अच्छा, अगर आप एक चीज को देखें कि अगर आपकी कहाँ है पेज, कोई मुझे मिल जाए यहाँ पे, अगर आपका डिमांड ज्यादा है, डिमांड ज्यादा होगा तो क्या होगा, ये चीज बढ़ जाएगी। ठीक है, ये चीज बढ़ जाएगी ना, यू विल रिक्वायर मोर एरिया। ठीक है, इफ डिमांड इज मोर, सॉरी, ये मैं, the cross sectional the area requirement will be higher, so you have to select a heavier structure. आपने जो मेंबर देखे हैं, आपने रूफ ट्रसेस देखी होंगी, सिर्फ रूफ ट्रसेस देखी है ना आपने?
यस सर।
हाँ, तो उस पे तो इतनी डिमांड नहीं होती। उसमें अगर आप इसको ले लें, स्ट्रट को ले लें या टाई को ले लें, चलें ये टाई है, तो उस पे एक्सियल लोड बहुत कम होगा। अगर आप रियल स्ट्रक्चर को देख लें, कहीं बिल्डिंग पूरी स्टील स्ट्रक्चर की बनी होगी तो ये मेंबर वहां पे यूज नहीं हो सकेंगे, क्योंकि इनका इफेक्टिव एरिया दे आर वेरी लेस, बहुत कम है। तो ये सारी चीज इस पे डिपेंड करती है, और अवेलेबिलिटी पे डिपेंड करता है कि आपके पास कौन कौन से क्रॉस सेक्शंस अवेलेबल हैं। अभी हो सकता है कि ये जो एंगल्स हमने सेलेक्ट किए हैं ये पाकिस्तान में अवेलेबल भी हैं कि नहीं, मेरा नहीं ख्याल, लेकिन यूएई और उधर तो अवेलेबल होंगे ना
सर। यही बात मैं कह रहा हूँ कि यहाँ पे अवेलेबल ना हो तो फिर क्या करें?
फिर आप कौन सा सेक्शन यूज करेंगे? प्लेट यूज कर लें। आपके पास A36 स्टील नहीं है तो फिर आप मैनुअल के डिजाइन टेबल्स भी नहीं यूज कर सकते। तो देन व्हाट यू हैव टू डू इज, आपने मेंबर लेके पहले उसकी FY और FU कैलकुलेट करें, उसको टेस्ट करें और उसकी FY और FU यूज करें, और फिर वो एनालिटिकल अप्रोच यूज करें जो हमने एग्जांपल 3.12 में फॉलो की थी। फिर डिजाइन टेबल्स आप नहीं यूज कर सकते। डिजाइन एड्स जो आपकी इसमें हैं AISC में, वो आप यूज नहीं कर सकते।
सर जनरली जो ब्रिजेस होती हैं सर, जैसे ये 410 का पुल जो है प्लस ब्रिजेस है सर, इसमें प्रैक्टिकली कौन से यूज होते हैं आजकल? थिकनेस
आजकल तो मैंने आई हैव नॉट सीन एनी स्टील स्ट्रक्चर ब्रिज, मैंने नहीं देखा। लोग डिजाइन ही नहीं कर सकते, पहली बात। दूसरी बात ये कि ये जो ब्रिजेस आपको 410 पे नजर आ रहे हैं, ये ब्रिटिश एरा में डिजाइन हुए थे। अभी मैंने नहीं देखा, मैंने मोस्टली जो स्टील स्ट्रक्चर देखे हैं वो रूफ ट्रसेस में देखे हैं, रूफ ट्रस।
सर तो क्यों आजकल तो सॉफ्टवेयर भी ज्यादा हो गए और उस टाइम पे तो
सेक्शंस नहीं है आपके पास, ये चीज नहीं है, ये चीज नहीं। आपके पास हाई क्वालिटी स्ट्रक्चर स्टील नहीं है, ये चीज नहीं है आपके पास। लेकिन सारी उम्र तो इस तरह नहीं होगा ना। अगर आप देखें फॉर एग्जांपल, एक कॉलम आपने एज अ स्टील मेंबर यूज किया हुआ है, उस कॉलम में क्या हो सकता है, यील्डिंग हो सकती है, और उसमें क्या हो सकता है, फ्रैक्चर हो सकता है। ठीक है, तो अगर वो कॉलम फेल हो गया तो आप क्या करेंगे, दूसरा सेक्शन लेके आएंगे, उसको रिप्लेस कर देंगे, बात खत्म। अगर वो कंक्रीट का होगा, चलें एक चीज मैं आपको बताता हूं, अगर मेरे पास यहाँ पे पेज है, ठीक है, मैं बताता हूँ। अच्छा, स्टिफनेस, फॉर एग्जांपल यू हैव दिस टाइप ऑफ मेंबर, ठीक है, फिक्स मेंबर, तो व्हाट विल बी द स्टिफनेस, 3 EI ओवर L3, क्या होगा भाई, किसी को पता है?
सर भूल गए।
मुझे भी भूला हुआ है, कोई बात नहीं। अच्छा, अगर ये कंक्रीट हो तो व्हाट विल बी द E वैल्यू, दिस मच, ना परुन ना लगे दिले दे यार, हाँ हाँ हाँ, सही था गोरम। और अगर ये कंक्रीट के केस में अगर ये स्टील होगा तो फिर क्या होगा, अगर आप स्टील यूज कर रहे हैं तो द स्टिफनेस ऑफ द मेंबर विल बी वेरी हाई। इसको देखें और इसको देखें, तो ये डिफरेंस है। तो अगर आप कंक्रीट में अगर किसी मेंबर की स्टिफनेस बढ़ाना चाहते हैं और आपके पास ओनली ये कि आप मूवमेंट ऑफ इनर्शिया बनाए, तो ये मेंबर इतना बड़ा बनेगा, इतना बड़ा, ये पता नहीं कितना होगा। स्टील में आप करेंगे तो इतना सा मेंबर होगा, बिकॉज दिस इज मोर स्टिफर देन दिस मटेरियल, दिस इज कंक्रीट। तो आपकी सेंस क्या कहता है कि यू शुड यूज कंक्रीट और यू शुड यूज स्टील?
सर डेफिनेटली स्टील।
यस, वो दैट्स व्हाई, मतलब ये, बट दिस इज वेरी रेयर, दिस इज वेरी कॉस्टली। स्टील इज कॉस्टली बट एडवांटेज देखें ना, मॉडुलस ऑफ इलास्टिसिटी 3600 और 29,000, दिस इज द डिफरेंस।
बट सर इफ यू सी द स्काई स्क्रैपर सर, तो जैसे एम्पायर स्टेट्स हो गए सर, वो सब स्टील स्ट्रक्चर हैं और वो 130 ईयर्स पहले बने हुए हैं। और अभी जो है सर हम कंक्रीट पे मूव कर रहे हैं, नए जो स्काई स्क्रैपर्स हैं वो सारे कंक्रीट की बन रहे हैं।
कंक्रीट, अभी कंक्रीट यूज करें, बाहर तो जो हाई राइज है उसमें तो स्टील है, वो तो स्टील है। अगर आपने कंक्रीट की एक बिल्डिंग बनानी है 40 मंजिला, तो आप क्या समझते हैं आपके कॉलम का साइज क्या होगा, बहुत ज्यादा होगा। अगर आप स्टील का मेंबर लेंगे तो उसका साइज कम होगा। दूसरा बात यह कि पेस ऑफ कंस्ट्रक्शन या स्पीड ऑफ कंस्ट्रक्शन विल बी फास्टर इफ यू आर यूजिंग स्टील स्ट्रक्चर। कंक्रीट में आप क्या करते हैं, फार्म वर्क यूज करते हैं, कंक्रीट पोर करते हैं, फिर क्योरिंग करते हैं। स्टील में ये चीज है नहीं। थोड़ी बहुत समझ आ रही है आप लोगों को?
यस सर।
तो अभी आपके पास थोड़ा सा टाइम आप लगाएं और मैनुअल में जाएं और ये टेबल जो है ये निकालें, ये वाला टेबल निकालें, और इस प्रॉब्लम को देखें। ये टेबल में आपको ये वैल्यूज मिल रही हैं कि नहीं मिल रही, ये आप चेक करें। अगर इसके अलावा मैं 5 मिनट तक आपका वेट करता हूं, फिर आपका कोई क्वेश्चन हो तो यू कैन आस्क मी, ठीक है? फिर उसके बाद हम ब्रेक लेंगे, ठीक है जी? एग्री?
यस सर।
चलें करें, निकालें चैप्टर नंबर 5। मैं इस पे चले जाता हूँ, ये वाला टेबल निकालें। आप लोग ये चेक करें कि ये टेबल्स A36 के अलावा और किस किस स्टील के लिए डेवलप हुए हैं। अदर देन A36 स्टील। हाँ जी, किसी को मिले? Did you find success in finding these table in the manual?
सर ये वाला तो फाइंड कर लिया।
अच्छा, तो उसमें यही चीजें हैं जो मैंने बताई हैं उधर जो स्लाइड में।
यस सर।
चलें ठीक है, दैट्स गुड। कौन से पेज पे हैं?
सर ये 515 पे।
515। अगर जिन लोगों ने नहीं, वो दे कैन लुक इनटू चैप्टर नंबर 5 515। ओके
सर टोटल पेज नंबर 741।
741 पे। अच्छा 741। ओके। और एंगल्स के अलावा और टेबल्स भी हैं और शेप्स के लिए भी हैं?
जी सर।
ये टेबल्स सिर्फ एंगल्स के लिए हैं कि और शेप्स के लिए भी हैं?
सर ये सिर्फ एंगल के लिए।
अगला टेबल नहीं है इसमें, कोई आगे स्क्रॉल डाउन करें।
सर इसके बाद जो है वो WT शेप्स है।
ठीक। So you can find these tables not only for the angles, but you can find these tables and you can use these tables for wide frame section. And I'm sure these tables will be also there in the manual for the channel section. So the tables are available, but the only drawback is that their assumption between the effective and the gross area, okay? The U value is fixed. So this is the only drawback of these tables, and you have to manually check the effective and net area. Okay, so this whole procedure I have demonstrated with this so we have repeated example number 3.12 using the design aid or design tables or tables 5.2 and onwards. Okay, so I hope these things will be आप लोगों को ये clear होंगी. So we will take a break and we will come back at 9:50. What is the time? Yes, we will come back at 9:52. Okay, and if you have any question, you can note down your question and you can ask me your question. Okay, it is better to listen to the lecture rather than listening to the recording, because it will save a lot of time, a lot of your time, because you do not have a lot of time, so you will listen to the recording, or it is better you should ask me or you should listen to the lecture. Okay, so with this I will stop the recording and we will meet back at 9:52. Okay.